I left you with that. After showing you how to do this one, what are your options? Are those two binomials the same? No. Was it a pain in the rump to try to factor that? Or was it super easy when I changed it to one thing? So what would this be? A squared. And what would this be? Is it the same as that? So can I make it B? A? No. But if I make it B, it's real easy, isn't it? Because that's square minus square, right? So it's A minus B, and then what? A plus B, right? Now it's super easy, isn't it? What's A? X minus 7. What's B? X plus 3. So it's X minus 7 minus X plus 3. What's X minus 7 minus X plus 3? What's X minus X? 0, yes? Do I write it? Of course not. What's negative 7 minus 3? Negative 7 minus 3. Negative 10. That's the first bracket, right? Maybe. Possibly. Maybe. And the second bracket is X minus 7 plus X plus 3. What's X plus X? X plus X. 2X. Right? And what's negative 7 plus 3? Negative 4. Everybody cool? Is it done? Why not? I'll give you a hint. The red circle is hovering over why it's not done. What can come out of there? There's no equal sign. There is no other side. You can divide that by 2 and bring it out to get negative 20 X minus 2. Okay? Is everybody good with difference of squares? Again, that's grade 10. There is nothing new. We have done nothing new with factoring. We are completely reviewing. Is everybody okay with it? All right, now we get on to the one that really causes people trouble. A trinomial where the first term doesn't equal 1. So I'm going to remind you, x squared minus 16x plus 48. Can you factor that? This is just a reminder from last day and last year. What is that factored? I need numbers that multiply to what and add to what? Multiply to 48 and add to negative 16. What are they? Yep, x minus 4, x minus 12. Everybody remembers that, yes? Okay. So now we're going to change it up slightly. We're going to do these questions. 3x squared minus plus 8x plus 4. Now, all of you know how to factor this. I know of 3 methods to factor this. I know the method I was taught when I was your age, which is very cumbersome. I don't really like it, but there's always 1 or 2 kids in the class that do, so I like to show it. Then there's the way that I learned myself when I was trying to teach math. I stole it from some teachers in Australia. And then there's a 3rd way to do it that was shown to me by exchange students from other countries. I don't like that 3rd way because the 3rd way makes for a lot of guessing. And I don't like guessing in math. Okay? So I'm going to show that 3rd way last. Everybody understand? I'm going to show you the way I learned from the Australian teachers because I find it to be the easiest one. But it doesn't make a lot of sense, so pay close attention. Yes. Yes, the box method is the way that I learned from other exchange students. I never learned that when I was a kid. Yeah, okay. I don't like that because you have to guess. When I show you the way I'm going to show you right now, there's no guessing. Because when you do that box method, you always have to try. Well, is the negative here? Is it here? Is it 3 and 6? Or is it 9 and 2 to get 18, right? Yeah. Yeah, there's all these weird rules with the box method. If you learn what I'm about to show you, there's no guessing. Okay? So, here's what we do. What number was right here that we don't write? It's a 1, correct? So that 1 goes to everything in this polynomial, right? If I were to factor out a 1, I could multiply that 1 back in there, couldn't I? Everyone agrees? Okay. So what do I have here? A 3. Now I can't really factor out that 3 because it's going to make a bunch of fractions, right? But at the end, if I factored out that 3, I would send that 3 back into everything, right? This first term is 3 times bigger than this first term, isn't it? Everyone agrees? Okay. So here is the way that I like to do these. Because this is 3 times bigger, when I was over here, I was looking for factors of 48, right? That's my first step over here. Correct? Everyone agrees? If this is 3 times bigger, should I be looking for factors of 4 or factors of a number that is 3 times bigger than 4? 3 times bigger than 4, yes? So when I do these, my first step is I take that 3 and I multiply it by 4 because I know I need factors of something bigger than 4 because this polynomial is bigger than this polynomial, yes? Right? Yeah. So what is 3 times 4? So now I'm looking for factors of 12. Now, these guys had to add to 16. After I do that first step, the next 2 are the same. I multiply to 12 and I add to 8. What are they? 2 and 6, right? So I have x plus 2 and I have x plus 6. Now please notice I've left a big space there. There's a reason. Our end goal when we're factoring is division, isn't it? Right? We have to divide to do factors. Have I done any division yet? No. As a matter of fact, to get 2 and 6, I had to multiply, didn't I? So now I'm going to do a division. I wouldn't know 2 and 6 unless I multiplied, correct? So now I'm going to divide out that 3. Everybody cool? Now, what would Mrs. Bad Crumble want you to do every time you see a fraction? Simplify it, right? Can I simplify this? No. Can I simplify this? Yes. So I would get x plus 2/3 times x plus 2. Everyone Everybody cool with that? This is no good, is it? So that 3 comes back to the front. And I get 3x plus 2 times x plus 2. Now check it. Is 3x times x 3x squared? Yes. Is 2 times 2 4? 3 times 2 is 6. 2 times 1 is 2. Is 6 plus 2 8? And there is my answer. Does everybody see this? I chose addition in both points because that's the easiest one to do. Everybody cool? That's the way I showed you last year. Well, I actually showed you 3 ways last year, 3 different colors. I showed you this. I showed you what I'm about to show you. And then I also showed you the box method that I don't like. If you get this, then stick with it. Because this is, honestly, I've been doing this for 17 years. This is the best one. The only thing you got to do is remember this move at the end. Okay? There is another way to do it. If you don't get this, I'm going to show you another way. Okay? The other way you can do it is this. Starts the same way. I still need to multiply to 12 and add to 8. Still 6 and 2, right? So I rewrite this as 3x squared plus 2x plus 6x plus 4. Now please notice, these guys make 8. Is everybody cool? Now, this is the way I learned it when I was your guys' age. I put a bracket there, and I put a bracket there. Can I do a GCF here? X, right? So I'm going to take out an x. And what does that leave in there? 3x plus 2, yes? Can I do a GCF here? What is it? 2 plus 2. 3x plus 2. Now what do you notice about that and that? They're the same. So aren't they a common factor? Because isn't this x times that? It is, right? So that means I can take 3x plus 2, and if I divide that out, what am I left with? X plus 2. And I have the same answer. This is the way I was taught. This is called decomposition. Some students in the 17 years I've been doing this actually prefer this method over here to this method over here. I don't. I like this method in red. And then finally, there's the box method, which I really hate because I don't actually know how to do it because it's all guessing. And I think this is how it goes. You draw a box. And you have to decide, what's the first step, Sarav? You draw a box. Oh, that's different. That's for when there's no first number. But that works too. And you have to do, I don't even know how to do it. So I don't even want to show you. If you know a third way to do this that requires you to put some numbers there and some numbers there, and then you cross or something, if you were shown something like that and you know how to do it, go ahead and use it. I hate it because you have to guess. And why guess when you have 2 methods that give you the exact answer right away? Does everybody understand what I'm saying? Yes.
In the second method, what do you do to get that black?
Well, if I gave you this, okay, watch. If I gave you x times a plus 2 times a is the same in both, right? So I'm going to divide by a. Now remember, when we do greatest common factor, when we do our dividing, the thing we're dividing goes outside, right? The factor goes outside. So I would get A out here, and then I would put all my answers, right? So the A's cancel x, the A's cancel plus 2. A is just my 3x plus 2. Okay? That's something that a lot of you guys, a lot of kids don't understand that. And don't write this down for a second, ladies and gentlemen. I need you to be aware of something. 2x. What are the factors in that monomial? I'll ask a different question. How many factors does that have? Okay, I need to change this question again. What is a factor? Yes, Sukpal? No. What is a factor, guys? Okay, I got to change this question again. Holy crap. What of the three numbers that I've written on the board there, which of those three are factors? Excellent. Okay, so everybody understands that 6 and 3 are the factors, right? Okay, so now I'll ask again that second question I asked. What is a factor? Anything that is multiplied together is a factor, right? Good job, Burke. So now we'll come to the question that started this mess. How many factors are there in that monomial? 2. What are they? 2 and x, because that's 2 times x. Yes? Okay. And then I'm going to give you this factor. 4y. What are the factors in that one? 4 and y. So that is 4 times y, yes? So now I'm going to give you this. 2x plus 4y. Can I factor that? Can I GCF that question? Yes, excellent. What is it? What's the greatest common factor there? Go for Myers. Yeah. Terrific. Thank you. What is the GCF here? 2. So if I was going to GCF, I've decided on my GCF, it's 2, right? So I'm going to divide it all by 2, and I'm going to write it as GCF x plus 2y, correct? Can everybody do that? Okay. So now, again, you don't need to write this down because you already know it. So then, 2x plus 3. Now, what are the factors? Go back to the very first thing. What is a factor? 2 things that multiply together. At least 2 things, right? Okay. Do I have 2 things multiplying together here? What are they? That's one, and this is the other. Now, somebody always says, but Mr. Myers, that's x plus 3. That's not a single thing. What do those do in math? They make it one thing. They group it together, just like they did in exponents. So, if those are my 2 factors, and then I add 4x plus 3, what are my 2 factors there? 4 and x plus 3. So these are the same factor, aren't they? Actually, I'm going to make that 5 and x plus 3. So these are the same factor, aren't they? Does that make them common? So that means I can divide by x plus 3 because that's the common factor, isn't it? Now, if we were going to write this out, where do I write the GCF? It goes on the outside, and what stays on the inside? The answers to these divisions, yes? So they cancel, 2, they cancel, plus 5. Finish that question off. X plus 3 times what? 7. Does everybody understand this concept? A factor can be anything inside brackets. Doesn't matter how big it is. Everybody cool? Okay, so now I want all of you guys, you're going to do one easy one by yourselves using whatever method you choose. Then I'm going to give you a difficult one. Okay? We'll do the easy one first. And remember, if you don't find it easy, is that okay? Yeah, because when was the last time you factored trinomials? Yeah, a long time ago, right? And I know you all think that us math teacher nerds sit around drinking beer, talking about football, and then somebody says, hey, let's factor some trinomials. And then we all go, yeah! And we all try to give each other high fives because we're math nerds we miss. Do you think that happens? Good, because it doesn't. So if you are concerned about this, don't worry, you're going to get tons of practice. So here is the one that you should be able to do. This one you should be able to do with one of these two, or possibly a third method if you learned that method in another place. Pardon me? Yep. Well, I'm trying, Luke. I really am. I'm tapping. It ain't moving. Huh. That enough? Okay. I'm going to wait a moment or two longer, then I'm going to work through it with my method, because it's the one I like. The Australian method, yes. It is not mine. I should look that up, Sarav, because some kids really like it. It makes you guess. Right? Like, when you do my method of either one, you always know your factors, right? There's no guessing. But when you do that box method, you have to try this or this or this. You have to do it like 3 times till you find the right answer. Yeah, right? Then you got to think all these weird rules. Oh, I have a negative, so can I put it in the... No, I can't put it in the bottom. It's got to go in the top right. And then you're just wasting so much time when all you got to think about is the numbers. Okay. So what do I got to multiply to? To negative 10. What do I got to add to? Positive 3. What are the factors of negative 10 that add to positive 3?
5 on negative 2.
It's going to be x plus 5 and x minus 2, correct? What did I have to multiply through here to get the 10? 2. So what do I have to divide out at the end? 2. Are there any factors there, any fractions there that simplify? That becomes x minus 1, correct? That doesn't simplify, so once I'm done simplifying, I bring the 2 to the front. 2x plus 5. Now I check. Is 2x times x 2x squared? Yeah, sure, you betcha. Is 5 times negative 1 negative 5? Yeah, sure, you betcha. If the first and last work, does the middle work? Yeah, and I'm done. Can everybody do that? Yeah? Everyone remembers this now, one way or the other? I didn't teach all of you grade 10, so I don't know what you learned. But if you were in my grade 10 class, you definitely saw these two methods. Everybody good? Does anybody know the brackety method? Does anybody know it? And I'm really speaking to people from other countries right now. Because I assume, Julia, you've done this before?
I did, but I don't remember because it was a long time.
Yeah, because it was like grade 6. Yeah.
I don't know how to do the
Okay. But one of these makes sense to you? The red one is cool? Okay. All right, so now I'm going to write one up that I've already given you a really good tool for how to solve it. I want to see if you can figure it out. Let's go with... This is about the hardest kind of factoring you have even possibly seen, is one of them. And I've given you a good tool for fixing that. Talk to your neighbor. It's hard. See if you can figure that out. There's two ways to do it. There's the shortcutty way I taught you, and then there's another way that you could try. I'm going to give you a small hint by doing some highlighting. That should have helped everybody out quite a bit if you weren't sure of how to start this. The x minus 7 makes it ugly, doesn't it? Right? The x minus 7 makes it ugly, yeah? How can we fix it? Change it to any other letter. Isn't this question the same as 5a squared minus 12a plus 4? Isn't it the same? And we can do this in our sleep, can't we? What do we have to multiply to? 20. What do we have to add to? Negative 12. What is it? Negative 10 over what?
5.
5. And minus 2 over what? 5. Does that simplify?
X minus 2.
That becomes 2. Does that simplify? No. So where does the 5 go? To the front. So I have, what do I have? I can't write yet. My computer's frozen. What do I have?
A minus 2.
A minus 2 and
5A minus
5a minus 2. Now, there were no a's in the original question, so what do I have to do with that right now? Rewrite it for a. X minus 7 minus 2. What's that? X minus 9. 5. I got to wait because my computer is, top of the line. 5x minus 7 minus 2. What's 5x minus 7? That's 5x minus 35 minus 2. X minus 9. 5x minus 37. Can everybody factor to here? In one way or another. 5 times 7. I distributed. Okay, now I cannot stress this enough, you guys. You have to be aware of this simple fact. You now have 12 years of math practice, right? Well, 10, 11 and a bit, because you didn't done math, kindergarten to grade 10, right? Everything you have ever done is coming together in the next 2 years. So even if it was something you learned in grade 4 and never did again, which is a big problem with math and BC in particular, they expect you to remember that thing that you were taught once in the 4th grade. Do you all understand what I'm saying? Everything you have ever known, you need for this math class. Which is why some of the other countries in the world tend to do a little better at math, because they don't teach you something in the grade 4 and then never talk about it again until grade 10. They keep doing it all the way along. Everybody cool? Okay. I want to shut up my pie hole. You have a couple of pages of factoring here. I know, guys, I know that this is dry. I know that it's not, fireworks, awesome. I can't even tell stories to make it fun. Right? I can't. It just sucks. But it is so important to higher level math that we have to, and I hate using this word, we have to master it. We have to get so we can factor everything if you're planning on going to higher level math. If you're not, we're going to do a lot of factoring this year at least. So it would behoove you to learn how to factor. But if you're planning on doing any higher level math or physics or chemistry, you gots to be good at this. Okay? So, you got 2 pages in your book. I think it goes to page 56. I want you to stop at 56 where it says factoring a sum or difference of cubes. Stop there. Okay? Because that's crazy.